Hello everyone, welcome to my channel. This is Naresh. Today's session we will talk about inverting amplifier, non-inverting amplifier and unity gain buffer or voltage follower. We'll see all these topics in detail. First we'll start with inverting amplifier. First, if you see the input connected to the inverting pin of op amp and the part of output which is taking to the inverting terminal of the op amp. So this configuration we will call as the inverting configuration because that input is connecting to the negative terminal of the op amp and the feedback we are providing through R2 and input we are giving to R1. So in previous lecture I have explained about the open loop drawback. There we can't control the stability or gain of the op amp in open loop condition. So to control the gain of the operational amplifier, we should provide the feedback, that is negative feedback we have to provide to control the gain of the op amp. So in this configuration I have provided the negative feedback through R2 resistor. So now we will analyze this circuit to get the closed loop gain. So now you see this input we are connected here and output through R2 we have connected to this node. We'll assume this node is Vx. To take the current, this one is I1 and this current is IF. So this is, we assumed ideal op amp. The current entering into the op amp always 0 amps because the internal input impedance of op amp is very high. So the current entering into the terminals is always 0. So the I1 is equal to IF by using this at this node. So if you see I1 is nothing but V1 minus Vx divided by R1. I wrote the current equation from here to here and is equal to, for IF if it is Vx minus this is I have taken V0 by divided by R2. So now you see in previous lecture I have explained about the virtual short. Now we can apply the virtual short here because this is connected to negative feedback and the op amp is ideal. So we can use our virtual concept. What is virtual concept? Whatever the potential at this pin will appear in here. So now by using this the Vx we got is 0 volts. So same thing will substitute in top. So V1 minus 0 divided by R1 is equal to 0 minus V0 divided by R2. If you arrange this equation we will got V0 by V1 equal to minus 2 divided by R1. If we closely observe this equation, the negative sign indicates that our output is inverted version of the input. Means if I provide input in this fashion, I will get output like this fashion because this is inversion of this portion. So this is inversion portion of this part. So the negative sign indicates that we are getting 180-degree phase shift between input and output. So this what the relation between V0 to Vi is the closed loop gain. So we got closed loop gain as minus R2 divided by R1. By simply adjusting the values of R2 and R1, we are in the position to control the closed loop gain. This was not happening in the open loop configuration. So finally we can control the closed loop gain by taking the values of R1, R2. So this is all about the closed loop gain of the inverting amplifier. Now if you see the input resistance and output resistance of inverting amplifier, I mentioned here this is R1, means the input impedance or input resistance of this configuration is R1. The output resistance R0 is 0 ohms for this particular ideal inverting amplifier. Now we'll see non-inverting amplifier. If you see this, the input is connected at non-inverting terminal as well as the feedback we have taken at negative terminal of the op amp. So this provide the negative feedback, and input I have connected at the pin of non-inverting terminal. So this entire configuration will call as a non-inverting amplifier. Now same way we will analyze this circuit for closed loop gain. If you see the here, so same way the internal impedance of the op amp is very high, so it will take zero current, and op amp is idle, the gain is very high, and input we are providing here, and we will find the relation between V0 to Vi. This R2 R1 are providing are able to control the gain of the circuit. Now we will derive the equation for closed loop gain. So now if we take again this, I will take as a Vx. So now I will take one current, this one I1, and this current IF. If you write the equation for the I1, it is simply 0 minus Vx divided by R1. Sorry, now if you take this current I1 equal to IF, because this current is 0, this at this node the entering current I1 is equal to the leaving current IF. So that's why I have taken this equation. Now if you see I1 is from 0 to Vx divided by R1. IF is Vx minus V0 divided by Rf. I will write that one, Vx minus V0 divided by R2. So now again we'll use the virtual concept, virtual short. So at this pin the voltage is V1, so now we got Vx equal to Vi. So now we'll substitute in the place of Vx, I will put Vi divided by R1 equal to Vi divided by R2 minus V0 divided by R2. If we rearrange this equation, we will end up with V0 divided by Vi equal to 1 plus R2 divided by R1. This is the equation for closed loop gain of the non-inverting op amp. So if you see here again, the gain of non-inverting op amp is controlled by again R2 and R1 resistors. R2 and R1 resistor, the entire closed loop gain we can control. So if you see here, this is ideally is positive value. So if you give the input at this terminal, output also in phase with V0. So we are getting 0 degree phase shift between Vi and V0. This is all about closed loop gain of the non-inverting amplifier. If you see another two characteristics, input impedance and output impedance. You see the input impedance of this non-inverting amplifier is infinite, and output resistance is 0 ohms. This is ohms. So if you see the ideal voltage amplifier characteristics of input and output resistance, it is matching with our non-inverting amplifier. So compared to the inverting amplifier, non-inverting amplifier we can use as the voltage amplifier in our circuits. So next topic is unity gain buffer or voltage follower. Actually this is here you see, this is a special case of non-inverting amplifier. Why it is special case is, you take here R2, here R1. So sorry, here we will take R1 as this we will retain. See if you see this is our non-inverting configuration, because Vi is connected non-inverting terminal. Again V0 through feedback we have taken at this point. But if you short the R2 and open the R1, means simply you short R2 and R1 open. So we will get now this form of circuit. So if you see again, analysis is same, but in case of what we got earlier, V0 by Vi equal to 1 plus R2 divided by R1. In this I will put R2 is short circuit 0, and this is open, means the nothing value. 0 is divided by anything is 0. 0. Now we'll got V equal to 1. So the relation between V0 to Vi we got is V0 to Vi is 1. So if you see V0 equal to Vi, So by using this, we can come to know, we came, the conclusion is the output voltage follows the input. So that's why we call this as the voltage follower. Whatever the input you apply here, we are getting the output here. That's why I mentioned V not equal to VI. But the question is, what is the advantage if you are getting output same like input? By using this amplifier, we are in the stage to get high input impedance and low output impedance. How we will see here. See, if this is the model for the voltage follower, because of the internal impedance of the op amp is very high, we open this path, and if you see the gain of the this circuit we got high, so v not nothing but vi. You can prove by this method also. The main advantage of this circuit is we can use as a buffer voltage amplifier, because if you see this high input impedance and it has low output impedance, the three only I mentioned here. The reason behind the unity gain is it is providing the gain of 1, and why you call this voltage follower is the output is following the input, so that's why we call as the voltage follower. So this is the summary I mentioned regarding inverting and non-inverting. If you see the closed loop gain, this is minus R2 times R1 minus R2 divided by R1. The input resistance is R1 and output resistance is 0 ohm. If you take non-inverting amplifier, the closed loop gain is 1 plus R2 divided by R1 and input resistance is infinite and output resistance is 0. These and all, when we solve the problems, we can use directly these two formulas.